Good morning and welcome to Lecture 3D, all the PID parameters together. So today we will learn how the three different parameters P, I and D are combined. So just a quick reminder of a closed loop system. So remember from the first lecture, a closed loop system looks like this. You have your controller, and that controller outputs a signal to your system or your process. Now, what the signal is that goes from controller to system is UT. So typically control textbooks will call this UT. Now the system process outputs something, so that's our output, our current output, and that output goes or is constantly measured by a feedback system. So feedback or sensors. And those sensors are constantly measuring the output, and this allows the controller to correct itself using this error block. So that's error. And remember, the input to that is the set point. So how are proportional, integral and differential combined? So firstly, we use U of t. So this is our control signal. And remember, UT is the output of the controller and inputs to the process or your system. And so UT equals Kp, which is a proportional variable or parameter, multiplied by ET, which is the error, plus Ki multiplied by the integral of the error, make that bigger, and then finally plus Kd, that's supposed to be a D, multiplied by the differentiation of the error, i.e. the gradient. So that is proportional. The integral, and that is the differential. And remember that combining these together makes the control signal UT, which is the output of the controller. So that is the output of the controller. And so now it's important to understand that PID entirely acts on the error. So acts on the signal error. And so by scaling different characteristics of that error signal, it actually produces this control signal which we can use to correct our system. And remember, error equals set point, our desired point, minus the actual current state, current output state. Okay, in summary, today we learnt that the control signal takes proportional, integral and differential to scale the signal error. This control signal is used to correct the system as a whole. Thank you. Next lecture will be Lecture 4a, where we will tune the PID parameters. Thank you. Hope to see you next time.